Hey, good morning, everybody. This is Mr. Aynesworth here, and we're getting into part 2 of our series in 7.4 in AP Pre-Calc, talking about the cotangent function, okay? In part 1, we went over what the cotangent looks like, how it behaves, and why it behaves it does. I mean, why does it have a range like that? And we connected with to the idea of having slope of the radius, and that's why it goes infinitely up and infinitely down. And part 2, we're going to switch functions. We're going to take a look at the reciprocals. Okay, so the reciprocal of the tangent function is called the cotangent function. Okay, so that's the first thing. So it's the reciprocal of tangent. Here we go. And so what we want to do is first is to explore the domain. Where is it undefined? Where are these vertical asymptotes? And that domain question is an important one. So we're going to start there. So what we're going to do is we're going to define tangent, okay? So if cotangent. So if tangent is sine over cosine, well, cotangent of theta is cosine of theta. Or theta is your input, it's your angle, divided by the sine of theta, okay? And you have to remember one important thing, and then you cannot divide by 0, okay? You cannot divide by 0. Okay, because of that, sine of theta, okay, sine of theta cannot be equal to 0. So you got to figure out at what angles is sine equal to 0 and restrict them from the domain. So it's all reals except those. And then wherever those are, well, guess what? They're vertical asymptotes. Okay, so on the unit circle here, we know that, if you zoom in here, we know that the y coordinates refer to sine, and at 0 radians, or 0 degrees right here, we can see that the sine of 0 is 0. And at 180 degrees or pi, we can also see that the sine of 180 or pi radians is also equal to 0. Okay, well, let's put the 2 and 2 together. So here we go. So because we know that theta, all right, which is our domain, all right, it's our input angle, all right, cannot be equal to 0, pi, 2 pi, 3 pi, all right, 4 pi, 5 pi, and it keeps on going on. So in general, theta cannot be equal to, okay, all reals except, all right, k pi, where k is some integer. Okay, I'm talking about 0, plus or minus 1, plus or minus 2, etc. Okay, so just multiples of pi, they could be negative or positive. And this is a periodic function, so just keep that in mind. So the asymptotes, the vertical asymptotes are at these values. So this is the domain, so keep that in mind. And it also gives them information on the vertical asymptotes, as you're going to see. So the first thing we do when we graph cotangent is we draw these red dotted lines as vertical asymptotes here, starting at 0. And we're going to draw a couple periods here just for fun, okay? So we have another one at pi, we have one at 0, x equals 0. We have one at x equals pi, and these are the what you type into Desmos too when you go ahead and take a look at it. Right? We have another one at 3 pi, or 2 pi and 3 pi, etc. There's an infinite number of these asymptotes. So the first thing you do is you draw your asymptotes, and then you have to explore where are the points, how does this function behave? And yeah, you could use Desmos, but you also have to evaluate it by hand, and so that's what we're going to do here first. Okay, so we're going to input these angles and kind of get an idea of what's going on. Okay, so remember, cosine of theta is defined to be cosine of theta divided by sine theta, and it's also defined as x over y, the ratio. Okay, you know that because tangent, okay, we knew tangent of theta was defined to be y over x. Well, guess what? This is a reciprocal, right? Okay, so we can look, when we look at the unit circle, which we're going to do, which is in the upper right-hand corner of the screen, we can evaluate cotangent of theta different ways. And here we go. And we're going to be using multiples of pi fourths here, so you might as well just go, put up the special right triangle here, the 45, 45, 90. Not 4 pi. I can't believe I wrote that. So I'm at 45 degrees, where we have an isosceles right triangle right here, where you can get your values for tangent at pi fourths, okay? And 3 pi fourths, 5 pi fourths, and 7 pi fourths, and so on. Not just from the unit circle here, but from this little triangle, believe it or not. Okay, so the first thing we do is we take the cotangent of 0, Okay, what is that? Well, if you look at 0 here, x is 1 and y is 0. So you have 1 divided by 0, and guess what? That is undefined. All right, so we just found our first asymptote, all right, right here, okay, at x equals 0, and we did that by substitution, right? We just did that by evaluating, plotting points, understanding the function by plotting points, which is what you do in Algebra 1, Algebra 2, pre-calc, calculus. So this is how you understand a function, okay? Next one, let's take a look at the cotangent of pi force. And again, this we did a mastery on this, and of all the 6 functions here, evaluating. What you want to do is you want to think, what's the tangent of pi force? Okay, and you got to remember, so katoa, just look at your little triangle here. All right, we know that the tangent of pi force is opposite 1 divided by adjacent. So 1 divided by 1 is usually 1. And tangent of pi force is 1. We know that. Well, if you take the reciprocal of that, you get 1. Okay, so remember, cotangent is a reciprocal of tangent. So if you know your tangent values, you know your cotangent values. Okay, the next one, we have cotangent of pi halves. Okay, and again, this is x over y. And if you look at the top of the unit circle here, it's x comma y. And if you take 0 divided by 1, you get 0. Okay, so you have 0 divided by 1 or 0. And then you keep on going. You get cotangent of 3/4 pi, which has a reference angle pi force. And if you look at the unit circle up here, tangent is negative in quadrant 2, so the reciprocal of a negative is a negative. So this is negative cotangent of pi force, which we just evaluated, so this is negative 1. And then you take the cotangent of pi, and that's negative 1 divided by 0, and that's negative 1. Okay, so negative 1 divided by 0, excuse me, negative 1, that's undefined. I don't know what I just said, but that's undefined. Okay, so we just found our second vertical asymptote here, okay, by evaluation. Okay, so then we plot these points and kind of get an idea of what's going on. So let's plot them. Okay, so 0, there's nothing at 0. There's an asymptote there. Pi force comma 1, and then pi halves comma 0, and then 3/4 pi comma negative 1, and so on. And I know we only have 3 points, but we're going to validate everything we do in Desmos here. Anyways, here, what happens is the function kind of goes through these 3 points, and it's also asymptotic to these lines. So it goes infinitely up, just like tangent does, and it goes infinitely down. So the domain, the range is all reals, okay? So it goes up to positive infinity, goes down to negative infinity, so the range is all reals. But why? Why does it behave like this? Okay, and then it repeats, of course. So if it kept on going from pi to 2 pi, I can repeat those values. So what we're going to do is we're going to shift over pi radians, plot a point, shift over pi radians, plot a point, shift over pi radians, plot a point, and then graph another period just so you can see it. Okay, there we go. So I just graphed another period just for fun, just by plotting the same 3 points as I did before. But why does the cotangent function behave like this? And it kind of looks like the tangent function, but reflected, right? And it's been shifted because it doesn't have the same asymptotes as the tangent function. So why? Okay, so we're going to do a little analysis here. This part I haven't done with you yet. And so let's check this out. So recall the definition of cotangent in terms of x and y. What happens to the cotangent ratio of x divided by y of all the coordinates on the unit circle? Okay, as theta, the angle, decreases from pi halves to 0. All right, so we're going to go in this fashion here. We're going to go pi halves rotate to 0. So we're going to rotate clockwise right here. And we're going to take all these coordinates here. And we're going to take all the x coordinates divided by the y coordinates and see what happens. And just do a little investigation. What's going on? And then I'll explore. I'll show you a different way to think about it as well. Okay, so let's do a little calculating here. It's not bad at all. Okay. So what do we have? We're going to take a look at, again, we're starting at 90 and go into 0. So let's take a look at 60 degrees first, and then 45, and then 30. Or pi thirds, pi fourths, pi sixths. So at the first angle here, pi thirds. All right, we have x divided by y. What would that be? It would be 1/2 divided by root 3 over 2. Okay, and then you take 1/2 times the reciprocal, 2 divided by rad 3. 2's cancel, and you get 1 over root 3. Use your calculator, you're going to get about 0.57. Okay? Now, if you take a look at pi fourths, this is an easier one, as you're going to find out. Okay, if you take the two coordinates here, they're both root 2 over 2 and divide them. So root 2 over 2 divided by root 2 over 2. Well, that's obviously 1. And then at pi 6, okay, the ratio of x to y, that's equal to root 3 over 2 divided by 1/2. Okay, and here, if you take rad 3 over 2 times 1/2, you multiply by the reciprocal. The 2's cancel, giving you rad 3, which is about 1.7. So if you take a look at your answers here, and you take a look at the ratios of x to y, you'll notice that it keeps getting bigger and bigger. Okay? Keeps getting bigger and bigger. Why is that? Well, watch this. Switch colors to blue and watch this. Okay, so I'm going to draw the distance of x here. This is x, or 1/2 units. So this is the x distance, okay? This is the second one, and this is the third one. And notice that the distance of x here, distance of x, is increasing. There's another way to visually think about it. Okay, how is that changing versus the y distance, okay, versus the y coordinates? Well, the y coordinates, you look vertically, right? So I'm going to switch to green now. So there's your first distance for y, and then here's your second distance, and here's your third distance. So here, the y distance, right, is decreasing because it's getting shorter. Okay, so x is increasing as y is decreasing. So let's make a little note of that. Okay, so in terms of the ratio here, so as theta, all right, theta goes from, let me see, as theta goes from 90 degrees to 0 degrees, right here, x increases, okay, x increases in size, x increases as y decreases. You got to ask yourself, why is that important? Okay, that means, or implies, okay, that implies that the ratio, okay, which is x divided by y, so again, x is getting bigger, y is getting smaller, okay, the ratio of x to y is getting really big. So take a moment and digest that there. So the ratio is getting bigger and bigger and bigger. Okay, if the numerator gets bigger and the denominator gets smaller, then the fraction size gets really, really big. Okay, and it's approaching infinitely. It's getting infinitely big. And that's why, if you take a look at the graph now, let's go back to the graph. That's why when you take pi halves and you approach 0, so let's zoom in here. You need to go from pi halves to 0. This is 90 degrees to 0 degrees. Okay, notice the function is going up. And the reason why is because x divided by y is getting, okay, infinitely big. And so it has to go up, okay, just numerically speaking. And that's the reason why. All right. And, you know, that's a little technical analysis here, and I hopefully understood that. I showed it numerically. I also showed it on the unit circle there using blue and green colors right there. And then, of course, you know, you can verify all this with decimals. So let's go ahead and do that real quick, because it's always nice to verify everything here. Let's see here. Let me turn off my previous functions. We want to talk about the cotangent function. So notice that I put some points in here and through here. And you got to type in your asymptotes to see what's going on. So let me make sure all the other ones are turned off. There we go. Okay, so I have my cotangent function typed in. Let me maximize this here. Okay, so there we go. So there's two periods of the cotangent function. Let me see if I can put this side by side here. Aha, okay. There we go. There's my cotangent values. There's my cotangent function. Let me see if I can get some values here. Oh yeah, look at this. Love it. I love Desmos right here. So there is the same graph. Two periods of cotangent right there. You'll notice on the right in Desmos here, 0, pi, and 2 pi are the asymptotes. And the points I plotted here are the same points I plotted on the left. How about that? Okay, so screenshot this. Do what we always do in class, and then bring in your Desmos graphs, and then add them to your file to make it complete. And just to recall, like you can oops. Okay, you can verify everything, with Desmos. Okay, all right. This is Mr. Aynesworth here. Hopefully that helped you out. This is part 2, talking about the cotangent function, and then in part 3, we're going to get into the secant function. Okay, this is a series of all the reciprocal functions. So hopefully that helped you out, and I'll see you in class. Take care.